Mission Log 29, Julian date 26028. This is Tal, your navigator for today's voyage through the realms of human thought. Welcome aboard the Science Book Club podcast, a vessel charting the brilliant ideas of contemporary science and illuminating the institutions at the frontiers of discovery. Our crew unites under a singular mission to advance science literacy through reading and fellowship, guided by the hand of measured altruism. We are honored to welcome Peter Brannen, science journalist and author of The Story of CO2 is the Story of Everything. In this sweeping work, Brannen traces carbon dioxide across deep time, revealing how this invisible gas has regulated climate, fueled life, driven mass extinctions, powered human industry, and now stands at the center of our planetary dilemma. By weaving geology, biology, chemistry, and human history into one continuous narrative, Brannen shows that CO2 is not merely a pollutant or a policy issue, but a fundamental actor in the story of Earth itself. His work invites us to see our warming planet as the latest chapter in a much longer and far more consequential story. And now, I yield command to our captain and founder, Mr. Mick to guide us into this vital conversation.
Story. Peter, thank you so much for joining us.
Thank you so much for having me. That was a great synopsis of the book.
Yeah. What first inspired you to write a book centered entirely on CO2? Was there an instance when you realized this single molecule could serve as a thread tying together mass extinctions, ice ages, and our present moment?
Yeah, so this book kind of naturally spun out of my previous book, which was called The Ends of the World, which was about the big 5 major mass extinctions in Earth history. And that book was really about the advances in that particular field of geology, which is these people who go out and study these extinction boundaries and try to piece together what went wrong in the biggest, disasters in Earth history. And the reason why I wrote that book is because I think there was sort of this idea in the popular imagination that mass extinctions are what happens when big rocks fall out of the sky, because that was so successful at explaining the dinosaur extinction. They found essentially a layer of asteroid dust in Italy in 1980, and then in 1990 they identified the big crater in Mexico, and so that story was like wrapped up with a nice, neat bow. And in the following 30 years, I think most people sort of lost track of the story after that, and in the following 30 years. Paleontologists went back to the previous mass extinctions, some of which are even bigger, looking for evidence of asteroid impacts. And instead what they found are these like really dramatic planetary climate change events driven by changes in CO2. And so I wanted to sort of update people on that, that there's this eerie relevance to the experiment we're running on the planet today with these like really big disasters in Earth history. But in the course of writing that book, which still kind of portrays CO2 in the way that I think most people think about it, which is it's this thing that when it gets out of control can cause ocean acidification and warming and deoxygenation, all this stuff we're scared about today. But in the course of writing that book, I had to really do a deep dive into geochemistry and geoscience and spent a few years just, there's an incredible learning curve of understanding the chemistry of this stuff. And I like the context that you hear about it in that world is much broader than just its role as, warming. I just noticed that it was central to basically everything I was learning about. And it's actually not that surprising because, we are carbon-based life, which people hear. And I don't think about that. I don't think they think about that often, that like actually the source of all that carbon, carbon-based life is ultimately CO2. So I really wanted to talk about these two incredible, like it's incredible that one substance has these two features. One is that it's the substrate of all life on Earth, which if that was the only thing it did would be incredible enough. And the other is that it is the primary knob governing Earth's temperature, as a famous paper puts it. And yes, it is scary when it gets out of control, but for the most part, it is regulated through this incredible planetary thermostat that has allowed the planet to be habitable for, in the age of animal life so far, hundreds of millions of years, without dropping into a snowball Earth again, or getting so hot that it kills everything. It's got pretty close in the Permian, but normally it's regulated through like what I described, this incredible rock wet, like you have it's coming out of volcanoes, but it's also being weathered somewhere else, and it's all very finely in balance. And so the while there is the scary climate aspect to it, I really came away from the book research and writing process feeling like just incredibly like just a deep sense of gratitude that I'm even, we're even here able to have this conversation in the first place. How many things um, had to go right biologically and planetarily to allow us to be here. And you pull on these threads too far, and you find CO2 at the middle of them and at all of them. So
Yeah.
that's why I wrote it.
Yeah. I mean, you make a great case of CO2 really being the story of everything. Why do you think people often don't think about CO2 as both um, the substrate and the thermostat, as you just said?
I don't know. I think it's because most people just encounter it in news stories about ongoing climate change. And it probably has been a while since people really engaged with, high school level, like how does photosystem one and photosystem two work in photosynthesis, or how does the electron transport change work in mitochondria, and how do we make living matter? How does that magic trick even happen in the first place? It was just to remind people that this it does have these twin roles, and a lot of it is wonky geochemistry. That's why people don't learn it. Like
Yeah.
I noticed about myself that I was fascinated in it, and I was kind of motivated to write the book because I thought if I'm fascinated in it, why hasn't anyone, written this book? There are versions of things that people have tried to do similar, but when I started to write it, I realized like, oh, there actually is a pretty high level of technical difficulty that's going to be pretty difficult to explain to a lay audience, and that was like one of the main challenges of the book. So yeah, I mean that's one of the reasons why I think people don't think about it that often is because learning something like the weathering cycle, it doesn't sound that interesting, and you're talking about weathering rocks and um, these reactions that precipitate carbonate in the ocean. Like I think most people's eyes just glaze over when they hear a lot of these words, but when you really engage with it, it is just like it's mind blowing.
Yeah, it's incredibly fascinating. Um, One of the most powerful effects of the book was how it stretched people's sense of time. How does looking at Earth through deep time change the way we should think about climate change today? What do we gain when we stop thinking in decades and start thinking in millions of years?
Mm. I think that you really can't understand how radical what we're doing on the planet is today without this deep time context. Because I think most people hear, oh, a few degrees in a century, what's the big deal? And once you realize, or to like, we put 38 gigatons of CO2 out into the air every year from fossil fuels, and those numbers just lack all context.
Hmm.
Uh, and once you realize how rare like global experiments like the one we're running on the planet are, how far back in time you have to go to find anything even remotely analogous to what we're doing today. So like the analogy in the book is you take a walk and every footstep is a century, and already after 200 footsteps, there's sea levels 400 feet lower, and there's woolly mammoths on North America and on Antarctica on top of North America, like a totally different world. You haven't walked that far.
Hmm.
And in order to get to anything remotely like what we're doing today, you'd have to go back tens of millions of years, which is equivalent to like hundreds of miles, if not thousands of miles on this walk back in time. And even then, the analogs aren't great. It seems like in rapid warming events in the past, driven by big emissions of CO2 from volcanoes, those were about 10 times slower than what we're doing today. So, um, the asteroid impact that wiped out the dinosaurs obviously was a lot more sudden than that, but there's not really anything in the middle, this centennial scale massive eruption of CO2 into the air. So I think you need to take with a grain of salt all the projections for the future because we tune our climate models and things on how the planet's behaved in the past, but we're kind of in uncharted territory with some of the stuff we're doing, and we shouldn't be surprised if the planet reacts unpredictably, or there's some surprises waiting for us in the future. So I think that is like kind of the thing that deep time gives you. It's just that, this isn't, you'll hear historians talk about the little ice age and that was climate change and it transformed human societies. But like, this is not even in the same universe as the little ice age. The little ice age was a regional event globally less than half a degree of cooling over centuries, and this is a sort of change that potentially in the worst case climate scenarios, which we're probably not going to do, just because I think it will be very hard to, 3 centuries from now, still have a working society if we're still burning fossil fuels like we are today. But you actually can reproduce like things like the end Permian, which I just think is mind blowing that that's in our capacity to do as a species. And once you learn how crazy these events are, how dramatic they are, uh, I think people sort of casually say, "Oh, we're in a sixth mass extinction," which in my first book, I think the good news is that in historical times, we've driven something like less than 10% of species extinct, even with how uh, dramatic and devastating in some cases a lot of the environmental changes have been over the past few centuries. The good news is there's tons of biodiversity to save, and we're not in a mass extinction yet, and you really don't want to be in one. The fact that it's even in our power, once you learn about how extreme and uh, just horrifying those events are, it's kind of amazing that we could even be in the same ballpark at some point in our future. So I guess, yeah, just engaging with the geological record really helps putting context and drive home just what unusual times we're living in right now.
Yeah, and I'm not sure if I caught it correctly, but did you say that you don't think that we'll hit the worst case scenario within climate change?
Yeah, I mean, so the worst case scenarios, if you see the highest emission scenarios that like the UN puts out there, just as like, here's like, it's probably not worth considering worse ones than this because they're not like physically possible. But those predict like 10 degrees C of warming by 2300.
Hmm.
So 10 degrees C is about as much temperature change as happened in the end Permian mass extinction that killed almost everything on Earth. And that took place over thousands of years. And this is like 3 centuries reproducing that. So that is really dramatic stuff.
Yeah.
Um, I mean, I think we're going to warm a few degrees. It's really going to be difficult for the sort of global networked industrial society to manage. I think we'll probably, you know, make it through. It's not going to be a lot of fun, but I just don't think that the worst case scenarios are probably going to happen unless, in the book I talk about people again because it's so unprecedented what we're doing. We should keep, you know, space for unpredictable positive sort of feedback stuff like that Daniel Rothman guy I talked to at MIT. Like his stuff really does keep me up at night because um, he, as I talk about in the book, has this idea that if you push on this on the global carbon cycle, the Earth system too hard, you might kind of lose control out of it. And he sort of provides a worst case possible scenario where our emissions just sort of send the carbon cycle off on its own, and you could reproduce something like the Permian with a lot lower emissions than just us putting it out there with fossil fuels. That something might awaken in the carbon cycle, like melting permafrost or the oceans burping up tons of CO2 that once that sort of stuff starts, then we won't have any control of it. So all of this stuff sort of just counsels the precautionary principle. Given that we don't know where the edge is on this stuff, it really is better to not push
Yeah.
it too hard.
Yeah, so I mean, you think we're going to make it through? Do you think that when you say like humans will, is civilization will it look dramatically different? Um,
I have no idea. I mean, the climate's going to look different for thousands of years. Like even if I mean, it will take 100,000 years for all the CO2 that we emitted to the air to get taken out by things like weathering, by things like the oceans overturning and the slightly more acidic oceans dissolving this layer of limestone at the bottom of the ocean. And that will help restore sea chemistry. And you'll have weathering of rocks over long term. And eventually all of this will get washed out and we'll be back on the trajectory where as a planet. But in the meantime, I don't know. I mean, I think humans are really this unpredictable X factor in all of this stuff. I think long term, I'm an optimist about our species, mostly based on Earth history, the stuff I talk about with the fact that the ice ages were really pretty volatile and difficult times to make it through. And, as I write in the book, it wasn't our thick hides or our fangs that kept us alive. It was the fact that we have this incredible thing, culture and technology, and we can pass it down through generations. And so humans are maybe the most adaptable species on Earth. And there's a ton of us, and we have wide geographical distribution, which usually are predictors of things that survive like scary events in Earth's past. So I'm not worried about us going extinct anytime soon, but I think the next few decades to centuries are really going to be a trying time. And in certain times in our past, we've responded to that by reorganizing society and innovating our way out and coming out on the other side even better. So, I mean, that's the best case scenario for what the next few centuries of global environmental change do to us as a species. But yeah, the alternative is, these are the stakes are really high. The alternative is we drive so much warming that it just, civilization collapses, which I think is more of a live possibility than sometimes you hear in the climate world. Because you get labeled an alarmist or a doomer if you say stuff like this. But as I write in the book again, like the global economic system is this complex, dynamic thing we don't fully understand, and who knows how that'll respond to like geologically unprecedented climate shocks.
Yeah. So in most scenarios, humans will likely make it through, but civilization and culture could look dramatically different if not
I
collapse in some senses.
I think it will have to just because the way and I don't know what the political solution that is to this, because there's a whole camp that I mention in the book called the degrowth people,
Hmm.
which like the logically it makes perfect sense, like why they prescribe the political program they do, which is like we all have to, um, underprivileged people in the world should be able to boost their standard of living up to a certain level, and that will be balanced by us in the West like voluntarily declining our standard of living. And I just can't imagine any politician with the like proposing that and having any success, or whether that's even, I don't even really think that's desirable. So I really don't know what the answer is. But I know that if you're literally premised on growth for centuries to, again, another reason why having a long, deep time scale in mind is useful is because sometimes you'll hear people talk about, oh, well, we need to get off the planet in a billion years because by then the sun's going to boil off the oceans. And, if you project anything like uh, our increasing material and energy use over the next few centuries to millennia, it just stops making physical sense. So, and that's not very long in a human time scale. Like you have archaeological sites that last thousands of years. So all I know is that if you come back to Earth in 2000 years and you're looking at how humans are living, it's going to look different just by necessity than what we're doing today. Because it'll either be physically impossible to keep growing forever, or you know, in our efforts to do so, we'll drive the planet, like the planet will correct us through things like climate change and stuff. So we're going to have to negotiate at some point a new way of living on this planet. I just don't know what that looks like in the short term, or whether it's advisable to, have a political project that's organized around that at this moment.
Hmm.
So I don't know. I mean, I really don't know what I think about this stuff. I'm sure some of you who are reading the book left thinking, okay, what do we do? What's the next step? And I don't know. I think I sort of just laid it out there. Here's how I have evaluated the facts, and you can take from that whatever you want, because I struggle with this stuff as much as anyone else.
Yeah. Um, so you describe carbon dioxide as the planet's thermostat, which is a metaphor many readers found illuminating.
Hmm.
Could you explain why the weathering cycle is so important for long-term stability?
Yeah, I mean, you can look at Venus for a demonstration of what happens when CO2 just keeps, um, soaring until now it's something like 99% of the atmosphere there, and it's uh, hot enough to melt lead on the surface.
Hmm.
Um, and what's incredible about this, like weathering cycle that I talk about, is if it threatens to get too warm, if CO2 starts rising, which sometimes it does, not just in these really dramatic, doomsday episodes of volcanism, but over hundreds, tens and hundreds of millions of years, you can subtly change how much CO2 is coming out of volcanoes, which makes the planet slightly warmer. But as that happens, the more CO2 is in the air and the warmer it is, the more you're evaporating water, and there's just more energy and more water in the system, which reacts with rocks faster.
Mm.
And the faster it does that, the better the planet gets at sequestering it away somewhere else. It, you know, CO2 reacts with rainwater, it makes it slightly acidic, and then you have these reactions with things like granites and basalts that eventually deliver that carbon and things like calcium and magnesium and things to the ocean, and those it precipitates out as calcium carbonate, which people are familiar with from like oyster shells and corals, and lots of plankton build their like these tiny little microscopic shells out of it. And eventually that falls to the bottom of the ocean, and that what was once CO2 in the air is now, rock that, if you go to Indiana or something and you look at the limestone, you can see that it's little sort of planktonic creatures, and sometimes you'll get larger thing like crinoids and all these cool sea life, but it's life precipitating a rock basically that at one point came out of a volcano. And the planet gets better at doing that the higher CO2 gets, which cools it off. And then if it ever threatens to drop too low, then all of these weathering reactions I talk about slow down because it gets colder and there's less water vapor and there's less storms. And so you just get less chemical interactions with the rocks, which leaves more CO2 behind. And then you warm the planet back up. So it's the planet. I mean, this is incredible that it works this way. And it's also incredible what a narrow balance it is that the planet has managed to navigate. So, 50 million years ago, CO2 we're often told, people talk about it in parts per million, which gives you an idea of how diffuse this stuff is in the atmosphere. There's not that much of it. So that's the equivalent of, so we're at 420 parts per million today, which is concerning because it was 280 before the Industrial Revolution. But that equates to like 0.04 or yeah, 0.04% of the atmosphere is CO2. And we still have an Antarctica still covered by a mile thick ice sheet. And when CO2 was 0.1% of the atmosphere 50 million years ago, there were alligators and palm trees in the Arctic Circle. And so this is how narrow this window is that the planet has to navigate. The differences of point whatever of CO2 dramatically changes the world this extremely. And in snowball Earth, both when it gets really cold and the incredible super greenhouse thaw out of it, it sort of shows you what happens if you go beyond those boundaries too far. You can either freeze the planet or you can make it just like this uninhabitably hot wasteland. So I'm glad that the readers that you guys latched onto this because I do really think that's such a fundamental feature of the planet that you don't hear very much about. So yeah.
Yeah. So which past climate event taught you the most about the risks we face now?
Hmm. Like I was saying, there are not really any great analogs.
Hmm.
So there's a couple that paleoclimatologists study because they're the best ones we have. One of them is this thing, the PETM, which I talk about in the book 56 million years ago, which is the dinosaurs got wiped out 66 million years ago, and then 10 million years later, it's a you get about the equivalent of uh, all the economic fossil fuels in the world burned over 5,000 years. That is essentially what happens. It's volcanic in that case because it's 56 million years ago. And you see the temperature rise like 5 to 8 degrees C. So all of that is sort of in line with what humans could do. But it's not a perfect analog because so some of the really old ones like the Permian, they're so long ago, the world looks so different. There's different parts of biology. It's in a supercontinent, which might screw things up. And so that, maybe that doesn't have as much to teach us about our how the planet will respond to warming for reasons that I can get into. But this thing, the PETM 56 million years ago, the continents are basically where they in the right place or where they are today, more or less. And you do have mammals and things, and you see a similar amount of warming and carbon emissions as we might eventually reproduce. But the world is also starting from an incredibly warm place. Like the mammals basically inherited the greenhouse of the dinosaurs. So the world's already something like 12 degrees C warmer than it is today. And then it warms even more in this event. So how much does that world have to teach us about the future, given that, there's one of the big things we're worried about today is melting ice sheets on Greenland and Antarctica. And this is a world without ice. And so yeah, I'm not sure which one has the most to teach us. People are really going back and studying a kind of, and I know this is very wonky and nerdy, but like when I go to climate conferences, people are really honing in on this thing that I sort of briefly mentioned called the Middle Miocene climatic optimum, which is 15 million years ago. So we're jumping again like 40 million years into the future,
Hmm.
where Antarctica does have an ice sheet. You've been cooling for, you cool down from that sweltering early age of mammals. Finally, to the point where Antarctica gets an ice sheet around 35 million years ago. And so this is 20 million years after that. And the Columbia River basalts in the Pacific Northwest are what is left over from another one of these big burbling, large igneous provinces I talk about in the book. And that warms the planet up to CO2 gets up to like 500 parts per million or 5 or 600, which is what we are projecting for like by the end of the century. And that world is 8 degrees C warmer than ours. So it's a really warm place, which is a little frightening. But it's also the case that this was thousands of years of the Earth adjusting to this new CO2 level. So if we melt Greenland or the Western Arctic ice sheet, that will take place over millennia, which then, you might have vegetation replace what was once ice, which is darker, which might absorb more sunlight. So that might boost temperature again. But these are the really long term. If we kept CO2 at the level it is today or at 500 parts per million for, hundreds to thousands of years, you might get a world that's 8 degrees C warmer. I think what is encouraging is that if we decarbonize, we stop putting CO2 into the air, the level of CO2 in the air would drop a lot because there are sinks for it on the planet that will just take some of that bite away. And then, at some point, even though right now I think it's sort of a boondoggle and not a productive use of money or time to really be investing in like basically CO2 capturing and sequestering techniques, just because like if you do that if you invent these things without stopping emitting CO2, it basically won't make a difference. But in the long term, we really do want to get our CO2 back down to probably before, probably around 300 parts per million. So at some point, we're both going to have to stop emitting and draw it down. And if you do that fast enough, you might not set in motion these long-term climate, these long-term things that take millennia to play out. Again, we don't know. It could be that the West Antarctic ice sheet has already passed some tipping point where it's just irrevocably gonna, just disappear over the next few centuries to millennia. And same might be true of Greenland. We just don't know where the tipping points are. So
Yeah. One thing I took away from the book was that extinctions are largely correlated with the rate of CO2 release. Um,
mhm.
and I interpreted that our rate is similar to the end Permian mass extinction.
Mhm.
Is that kind of a correct interpretation? Is there something, is there
It's
more?
similar. No, it's the only thing that is, remotely similar to what we're doing. It's just that it lasted a lot longer than what we're doing.
Okay, so I mean, if we were to produce the CO2 super eruption of capitalism or economics, um, we, we would we could end up in a situation largely like the in Permian extinction.
You could. Not all paleontologists or geologists agree with that. Some think that was just such an extreme event that it will never reproduce anything like it again. Others think it is a good, warning in the rock record of what can happen if you keep doing what we're doing. Like one of the reasons people think it might not ever it might not be the best analogy is Pangea, as I read about in the book, is a really weird place, and it has all of its own climate implications when you have all the land masses together for this thing called the weathering cycle. That not only are you putting tons and tons of CO2 into the air, but you're just not weathering any rocks because you have this vast arid interior. So you're not burying any CO2 while you're putting it all into the air. And so the planet is really struggling to manage its CO2. Plus, what's kind of amazing is that you don't even have calcifying phytoplankton yet. So things that photosynthesize in the ocean, plankton that photosynthesizes in the ocean, is not making like little shells out of calcium carbonate yet. That happens that happens later in the Triassic. So today we might have a biosphere that's just way more resilient to these kind of climate shocks because when you have things like that, you're adding this whole layer of basically tums to the bottom of the ocean that can neutralize like an ocean acidification event. Which is actually what you see 56 million years ago in this thing I mentioned, the PETM. You do see the what's incredible is, and one of the reasons why I got into paleoclimate and deep time stuff was because I went to the Woods Hole Oceanographic Institution and someone showed me the sediment core from the bottom of the North Atlantic Ocean, where you can see it's sort of white chalky stuff, and then it goes to red clays for like a meter, and then it goes back to white chalky stuff. And they pointed at that because that's the event where all the CO2 came out of these volcanoes, acidified the oceans. But then as the ocean sort of overturned, they dissolved this layer of essentially limestone at the bottom of the ocean, which is like eating it's why you eat a Tums. Those are made out of calcium carbonate, the exact same stuff. And it sort of helped stem the misery that threatened to get out of control in times like it did in the Permian. So when there wasn't this sort of safety break in the Earth system. So again, I don't know where I land on that either. Like, is it a good analogy or is it not? It's sort of it's that unknown, I guess, that it keeps me up at night. So yeah.
Yeah, is there anything unprecedented now compared to the previous mass extinctions?
Well, a couple things. One is that it's biologically mediated through this one weird species, humans,
Hmm.
which actually there is a mass extinction, the late Devonian, which I talk about in the first book, which seems to have been driven by the colonization of the continents by trees. So that's kind of a weird one.
Hmm.
385, 375 million years ago. So it totally transformed the Earth in a lot of great ways, obviously, because it kickstarted the terrestrial biosphere, but it also it took a while for the planet to adjust to this new thing on the planet. They sequestered a lot of CO2. They might have caused an ice age, so all sorts of stuff. Um, Sorry, I lost track there. What was the question again?
Um, is there anything unprecedented now
Oh,
compared?
yeah. So that's kind of an interesting thing that it's not a big mindless tectonic volcanic thing. It's through us. The speed of carbon release might actually be a little faster than some of the ones that were driven by volcanic CO2.
Hmm.
Um, Although I can think of one time when there was a rate faster of CO2 emissions, and it was when the asteroid hit the Yucatan Peninsula at the end of the Cretaceous and wiped out the dinosaurs. There's an estimate that it vaporized just basically what would have been like a Bahamas, which is all calcium carbonate. And that injected something like 400 gigatons of CO2 into the air instantaneously. So that's like 10 years of modern emissions, just like in an afternoon. So that's faster. Um, but still, we are kind of off the charts in that way. None of the big extinctions driven by volcanic CO2 happened on a world that had ice sheets on it. These all happened in much warmer worlds.
Yeah.
So worst case scenario, if we launched ourselves from what is essentially still an ice age planet into a greenhouse in a matter of centuries, that is something that you basically don't ever see. In all of Earth history, I don't think that ever happens. So that would be pretty dramatic.
And that
To
could that could essentially increase the rate of warming because of the feedbacks, the ice albedo,
Yeah. There's
move.
there's yeah, there's things you have to worry about with ice that cause these positive feedbacks. But yeah,
Yeah.
just if we're looking for things to, say, how are we unique? That's definitely one of them.
Yeah. Um,
And that's a problem because on warm planets that get a lot warmer, those cause mass extinctions. And so we're to go from a cold planet that gets really warm, all life on Earth is adapted to the sort of climate that of the last couple million years. So maybe that would make it more severe than an extinction that's driven by warming on an already warm planet.
right, because in the book you kind of highlight that we're an ice age species
Hmm.
to yeah. Um, do you think overconsumption and economic growth more than any single technology define the Anthropocene?
I struggle with the term Anthropocene because
Hmm.
mm, for a couple reasons. One, especially ones that started in like 1950, because you can see nuclear radioisotopes and from atomic weapons testing.
Hmm.
I think that's way too late. I humans have been transforming and modifying the landscape and having massive effects on biodiversity and ecology for their entire history.
Hmm.
So if we're going to have an Anthropocene, I would probably start at tens of thousands of years ago with the megafauna extinction, which I think in some people's minds, they think it's still up in the air. There's this debate about whether was it the climate or was it the humans? And it really does seem like without humans, there would not have been this extinction, um, because it's staggered over tens of thousands of years. It doesn't really line up with any particular climate event. Some of the climate changes in the Pleistocene before were much more severe, but for some reason, exactly mirroring human migrations around the world, all the like everything over 100 kilograms goes extinct in like, new land masses. Or mammals do at least. So I would vouch for an old Anthropocene if we're going to have one. But I also think that term gives us too much credit because it compares us to an epic. And what we're doing is so rapid and so out of control that it's not like geologic. The late Cretaceous lasted 46 million years. That's an epic.
Yeah.
And you're telling me this one started in 1950? Like, there's not the asteroid impact doesn't get its own epic for like that afternoon. And I feel like that's the only thing comparable that once this extremely out of control moment in history resolves itself in some way, then maybe then the next epic starts. But we much more resemble like a extreme boundary event between epics than like our own epic. And I also think people, yeah, if you don't have a familiarity with deep time, it inflates our importance in Earth history, where we've been here for a millisecond, and we'll be lucky to survive a few milliseconds in the future if we don't get our act together. So already crowning ourselves with like this huge moniker in geology seems like of a piece with our arrogance as a species. Like I think if we actually do live in an Anthropocene and it lasts as long as a normal epoch, like it's millions of years long, then that's a great sign. That means that we will have matured as a species enough to live into geologically relevant time skip bands and live in a way that is in concert with these sort of big global cycles in the Earth system that take hundreds of thousands of years. Because if we're going to last into the geological future, we really need to live in ways that are in keeping with things that take place over geological time spans. And what we're doing now is just like so instantaneous from a geological point of view.
Yeah, so I mean, essentially, if you were to widen the Anthropocene, like what part of humans really still define the characteristics of this age?
Um, I don't know. I guess it's like tech, if it's an old Anthropocene, then there was something that made this not very intimidating looking, pretty small animal capable of wiping out all the other animals it encounters. And that comes down to culture and technology, fire, and our big brains that fire allowed, and language, and like I think orcas teach each other games, and crows are very smart, and there's features of different animals that share some things in common. But I think the like game-changing thing that unleashed what humans became on this planet was the ability to generationally pass down knowledge and things that worked um, in a way that seems pretty unique in the animal kingdom. And our languages do seem pretty weird. They don't resemble bird calls or even other primate calls. It is this ability to transfer huge packages of information, like which in biology mostly happens through uh, genes being passed down and
Hmm.
creating different life forms that then the environment selects what works and what doesn't. And our little shortcut to the time scales of genetic evolution by just like evolving the culture around us on a subgenerational time span and then being able to pick out what works and modify it and improve on it. But yeah, I guess there's not anything in the rock record you'd see about that. Although people do find things in caves in South Africa from hundreds of thousands of years ago where you see these little scratch marks and they're trying to decide, ooh, is this representational art or what are they doing here? Is this the beginnings of kind of us being a clever species? But yeah, I guess I would start it with the once you start seeing a signature of the megafauna extinctions, which might go back over 100,000 years in Africa, because we think of Africa as the place with the big animals, but that's because they evolved next to this to us and adapted a little bit. But even there, you do see you do see a lot of big animals do start to go extinct when humans show up. So I
Yeah.
think that's when I'd start the Anthropocene. But it does. It's also true that there are these inflection points. So it's hard to start nowhere to start things. But 5 to 6,000 years ago, when you get these huge megalithic agrarian empires, that seems like a kind of phase change in our history as a species. Uh, Starting around 500 years ago, where one part of the world, Western and Northern Europe, start traversing the whole world and suddenly taking raw materials from all over and launching their they're launching the international relevance. That seems like a big the triangle trade in the Atlantic. Like obviously something big is happening in our the story of us as a species then. And then the Industrial Revolution, 1850, I think actually, if you're going to start it, if you're going to have a modern Anthropocene, I think it has to start around the mid 19th century. Once this planetary battery of old plant life in the crust, fossil fuels, which just absolutely dwarfs the amount of energy you can get at the Earth's surface. Once we start exploding that, that's really when the planet started changing on like a geologically relevant scale. Once this invention of the steam engine and the Industrial Revolution, that is the big moment I think in Earth history or in human history that launches us in a like geological relevance. So maybe I do like a newer Anthropocene, but
Yeah.
1950 seems too late. Like
I mean, would you maybe frame it as like our geological footprint starts when the footprint of other animals start to kind of disappear, or I mean,
yeah.
that's kind of what I was taking. But then you like a newer Anthropocene now.
Yeah. So one of the reasons why that isn't normally adopted, at least by the geologists who propose an Anthropocene, is because most epochs have like a layer in the rocks that you can find a signature of all over the world.
Hmm.
And like I was saying, so like the Cretaceous ends when you find the iridium layer from the asteroid, and you can find that everywhere, no matter where you look on the planet. And sometimes it's the first appearance of a certain, little weird little, marine creature or something, or some new genus or phylum shows up, and that's the boundary because you can find it everywhere. And the megafauna extinction happens, as I was saying, staggered over tens of thousands of years. So there's not really anything to point to. And that's why they like that layer in the like nuclear layer in the because you can find that in lakes all over the world and in ice cores. But you can also see when the Industrial Revolution starts in ice cores and in anything that is recording the atmosphere around 1850. Not only does like CO2 start rising in air bubbles trapped in ice cores that we drill out of Antarctica, so you can like you'll have a core and you can go up through the years and see what is in the different trapped air bubbles. And you do see CO2 starts to rise, in the middle of the 19th century. But you also see, and the reason why we know it's us, sometimes you'll get this question from climate, deniers or skeptics who will say, well, who knows, maybe that CO2 is from volcanoes or something. Who knows if it was us? But not only do you see CO2 increase in the 19th century, but you actually see it get isotopically way lighter.
Hmm.
And the reason is because plants, carbon comes in a couple isotopes, a heavier and a lighter one. And plants literally like the lighter one because it's easier to manipulate in photosynthesis. So plants are and us because we eat plants are like made out of lighter isotopes than just like the normal carbon in the atmosphere. And you suddenly see that get way lighter in the Industrial Revolution because we're burning tons and tons of old plants from Earth history. So
Hmm.
coal is just these old coal forests. And so you see the signature of CO2 going up, but also it's all from like burning plant matter. And that's because that's the plant matter that was dug up from the ground in England from these weird forests in the Carboniferous period.
Hmm.
So uh, that would be a good place to also be a marker for, if there's an Anthropocene. This thing that you can see all over the world recorded by air trapped in ice sheets or in, like calcium carbonate at the bottom, like a drill core, you'd be able to see that. And so, yeah, that'd be a good marker.
Yeah, interesting. Um, After spending so much time with deep time, how do you think about human agency now? Where does meaningful influence actually reside in individual behavior, cultural values,
Hmm.
policy, technology, somewhere else?
Yeah, I struggle with this because I do hope that there is a. Sometimes I say, oh, well, the difference now from these other mass extinctions is those were caused by sort of mindless things like volcanoes and asteroids. And this one's weird because it's humans, and so we have agency and we don't have to we don't have to go through with it. We have a choice. That's what makes us kind of unique. Um, but that sort of takes for granted the idea that there is a steering wheel on like civilization and global industrial society. And I hope there is. I hope there's sort of pressure points and meaningful levers we can pull. So I often get the question like, okay, what do we do about this? And it's probably not a good line for selling books, but like it's almost not useful to think about climate change on such a vast planetary cosmic scale because what is one person going to do about it?
Right.
Um, and it's going to require such a incredible variety of skill sets and things to meaningfully address it. So, like for instance, if you're good at like politically organizing and getting, signatures on ballots for climate issues, that's great. If you're an electrical engineer or a welder, that's also great because we're going to have to, double the size of the grid in the next few decades to decarbonize, and it will require people with all these technical skills that you don't really think of as climate related to climate change. But it is such a vast and complicated problem that I like find the thing that you can, the one pressure point that you can you can put on this thing or wherever the lever is that you can actually contribute to because it's not one person obviously can't it can't really meaningfully affect it. I think voting is important. Obviously, like people have charted that the current administration meaningfully is going to change the amount of carbon dioxide that comes out of the ground,
Mhm.
just based on changes in uh, like environmental, climate, and energy policy. So that mean like it the ballot like how you vote can like change the amount of carbon dioxide eventually ends up in the air. Uh, and also, this is going to be such a international like it's going to require such an incredible level of like international collaboration. Um, and it's a really thorny, huge geopolitical problem that obviously, I'm not a UN ambassador or like an envoy to China or anything, but I think it's good to, yeah, put people in charge who understand the nature of it. But I mean, the other thing is that like China really is the big story now. So
Yeah.
um,
Why is
it's
that?
got because they're both huge.
Hmm.
There's a billion people there. They are attempting like the most ambitious decarbonization like plan imaginable. They make 75% of the world's wind turbines and solar panels, and they have this incredible rollout of EVs and all sorts of other things in the renewable space. But they're also burning 4 times more coal than the U.S. ever did at its peak. And the hope is that if anyone's going to, if it's possible to decarbonize at the scale we're going to have to, then I think we're all kind of just crossing our fingers and because the US seems to have forfeit its role in this, that, China pulls it off somehow and um, drops its emissions to, zero by, I think they're claiming to do it by 2060. But they're still going up every year, even though they're behind schedule on their goals for 2030 already. And I think the hope is that if the U.S. isn't going to show any leadership, that if we're going to figure this out, then hopefully they figure it out. But there's all sorts of problems with obviously the Chinese regime and
Right.
that whole like. So I mean, this is not like a blanket endorsement of China or anything like that. It's just like that's the elephant in the room for climate these days. They are by like the 20th century was a story of you know Western development and fossil fuel use, and I tell that story in the book. But now the torch has sort of been passed because they are by far the biggest CO2 emitter in the world, um, just dwarfing everyone else. Um, but they are also the biggest, um, you know, decarbonizer or contributor to that too. So it's we'll see what wins out. But that's sort of the opposite of empowering for what I was saying earlier, where it's like it's going to take us all to everyone to pull in the same direction, and we all got to figure this out um, uh, because China's so big. So I don't know. I mean, again, this is another one of these things that I struggle with. What we're supposed to do about it?
Yeah, I mean, it seems like it would be unpopular to kind of cheer for China, but
Yeah.
I mean, our best case climate scenario could be with them sort of leading the way. I don't know if that's, I don't know.
Yeah, I mean, but the US has always had an incredible advantage in things like innovation, and there are things about that space that still are pretty unique. So ideally, we would have a role in this. It's just, as depressing to read the headlines that you guys are all reading every day. And I guess I like to think that this is, well, I mean, and also I don't mean to take just assume everyone's, political persuasion on this call, but it is it's certainly not good if you care about the climate to how the current administration's acting.
Yeah. Um, when you look ahead 100 years, what scenario feels most plausible to you?
What's most plausible?
Yeah.
100 years is kind of a long time. 2020 or 21, 25. Um, I think it's going to be warmer. I think sea level will be a couple meters higher than it is today. Um, Honestly, I don't know. I like it's very hard to it's very hard to predict the future. We have reasonable understanding of what the climate and stuff will look like, but what the human world will look like, who knows? I do think going back to the issue of China and recent human history, you do sort of see these rises and falls of global hegemons. Where I start the story with, the Habsburg Spanish, and then it was the Dutch, and then it was the British, and then once it switched to oil, then it was the US and the USSR, and then once the USSR fell, you had this moment of hegemony with the US. And if it really is true that renewable, like the next thing, in the same way that the UK was eclipsed once coal left the stage and the US, this oil superpower, took over the world, if it's true that the next thing is, renewables and EVs and electrifying everything, and China gets such a head start on it, then you can imagine, in this process of handing the baton off, then that would imply that the next century is theirs, or we'll get our act together. I think there will be, 100 years from now, we will have already realized how screwed we are with things like insurance, and like there's already this growing insurance crisis, and it's hard to insure houses near the coast or in dry places in California because of wildfires, and places near rivers because you have these unprecedented floods and stuff. And I think we will have already done quite a bit of adaptation to a newer, more volatile climate world by then. I don't know what our solutions will be, but yeah, I don't know. I don't know what I don't know.
Yeah, I mean that's fascinating to like really put it in the framing that it's kind of that world powers kind of become world powers because of their energy dominance.
Mhm.
I mean, do you think that that'll still be the case? I mean, especially with like AI and
Yeah, I mean that's another like
that's another factor.
X factor. Who knows?
Right.
There's some people who are, you can read the right Substacks and they'll tell you that in 2 years the entire world's going to be totally transformed by artificial general intelligence. And I just don't know what to do with those forecasts. Then you have other people who are very skeptical of the entire project and just think it's this big boondoggle. So that I just sort of bracket and say, well, I don't know what's going on over there. I think ultimately AI will be important. I think a lot of these like large language models and things that are just like producing slop online and, um, OpenAI says it needs to lose $500 billion by 2030 to stay afloat. And I don't understand where all the profit's coming from if it's just, a tool to cheat on your college papers and make, you know, goofy pictures of cartoon characters doing stuff. Um, but I do know people in biotech who use not that stuff, but they use like machine learning and stuff, and they say they can do in an afternoon they can do what used to take a decade of research in terms of like figuring out how things bind to proteins and stuff. And so I do think there's some genuine promise that in this area that does, could unlock some, real human flourishing in the future. It doesn't seem like the like financial or any of the incentives that the big companies now are towards that. I think they're all focused on trying to automate white collar work,
Hmm.
and get rid of paralegals and stuff, and not the stuff that actually would advance humanity and allow us to live, healthier, better lives. But in the long run, I don't doubt the fact that AI broadly could be a pretty big technology.
Yeah. Um, okay, I think I'm going to pivot to questions from our members. So Annemiek asks or says, your ideas about CO2 and its influence on our current society may be seen by some as rather radical. You argue
Mm.
that our lives are shaped by the creation of CO2 and that our overuse of it is influencing the future of society in multiple ways. What led you to this perspective, and have you experienced any negative repercussions from others because of these views?
I think, I mean, what led me to it was sort of what I was talking about before, is just hanging out with geologists and paleontologists and seeing how important this stuff is in a context far removed from sort of the way it's talked about in the headlines. Is just, as I was saying, an industrial pollutant, that it actually is much more important than that. What was the second part of that question?
Um, sorry. Have you experienced any negative repercussions?
No, actually, I think because I talk about carbon dioxide and climate change in this geological deep time context, which
Hmm.
is not how most people hear about it. Like for the most people, you read the newspaper and it's this pollutant that its future effects we understand because we have these climate models and they're on computers and it's theoretical and it's all decades away. And I think people have their minds made up about that because they've heard of it so much and they think of it as this theory for the future. And talking about, these alien worlds hundreds of millions of years ago where clever geochemists can, point at a layer in the rocks and show you, we understand how this changes climate because because of this bizarre kind of alien thing hundreds of millions of years ago. I've gotten emails from people who are, oil geologists or people in the oil industry who are like, I had never heard climate change talked about in this context before, but this is more familiar to me, and you've given me a lot to think about. This is interesting. So in some ways, it's people like reading about dinosaurs and paleontology, and it's sort of been a Trojan horse of being able to talk about this is talking about it in a way that people hadn't heard or had their minds made up about it before. Um, that I'm not really interested in modern climate change per se. Like the reason why I love science writing and why I love this stuff is because I'm fascinated by the Earth and the Earth system and how it like in these big transformative events in Earth history, what was going on there. Um, so for me, I'm inspired to learn about this stuff just kind of out of a sense of wonder about this planet. And I think presenting it in that way also, people can be more receptive to it than just sort of like a doomsday thing about the next few decades, which is not fun to read. Um,
Hmm.
and we've heard it a lot, and so no, I've rather than getting pushback from writing about it, I feel like people have been surprisingly receptive.
Yeah, I mean, I think that this is probably my favorite climate change book just because of how fascinating it was. So,
Mm, great.
yeah. Um, and then Stacy's question, she says, you mentioned that humans have grown the overall biomass of a land. Sorry, I'll restart the question. Um,
Mm.
You mentioned that humans have grown the overall biomass of all land mammals and that 30% of greenhouse gas emissions are due to the global food system.
Mm.
When global warming makes much of the Earth uninhabitable and non-arable, do you think the catastrophic impacts to the human population could keep us below the tipping point for cataclysm, at least long enough for the remaining population to transition to a cleaner society?
Wow, that's an interesting question. I mean, I don't write or research much about agriculture and the food system, but there is some, there are some pretty unsustainable trends there in all sorts of ways. We draw up water from these big aquifers that take thousands of years to recharge, like the Oglala aquifer in the out in the Midwest. Um, we mine phosphate from weird rock deposits all over the world, mostly in Morocco, and we spread that on our crops. But there's only so much of this like phosphate rock. People point to like by the end of the century, we're going to be running out of this stuff that fertilizes a lot of our crops. And unlike the nitrogen fertilizers that you can synthesize from natural gas, you just need to find rock, and there's only so much of it. So, and erratic weather and climate change will, increase droughts, but also punishing storms that will be bad for crops. There will be shifts in where the grain belts are. So it's true that while some crops will decline pretty significantly, others will actually be boosted in areas where they don't currently grow. So again, it's one of these pretty unpredictable things that I don't think we just take for granted because things have worked out for a couple decades and because it's so existentially important that I think people have a failure of imagination of thinking, what if the carrying capacity was lowered pretty dramatically? So it'd be great to have more smart people thinking about that. I'm sure they are. But yeah, I mean, it was interesting the way was it Stacy? Is that who?
Yeah, Stacey.
Yeah, the way she put it in that it's like, yeah, it's kind of it would be if it did work out as cataclysmic as she says, it is sort of this weird negative feedback to warming. So, if human civilization collapses, we're going to put out less CO2, which will cause less warming. So, in the book, I talk about how, yeah, you have these positive and negative feedbacks from the climate system itself, where you put a little CO2 into the air and a lot more can come out from, permafrost or wildfires or something. And there's also negative ones in their system as well. But right now, humans are the dominant component of this stuff. And so the unpredictable positive and negative feedbacks from the human civilization are some of the biggest X factors in all this. But yeah, that's a pretty grim one that I don't know if I had thought about before.
Yeah. Um, and then Amelia's question, she says, um, what do you think it will take to get more of the general public on board to believe climate change is real and start voting for informed individuals that will take action? Do you think things will have to get very bad before many will believe it's happening?
Um, yeah. Well, no, not very bad. But I mean, I think already people. One thing I'm encouraged by, and it's sort of a cliche, but like you meet young people and they really do care about this stuff.
Hmm.
Um, at least some of them. I'm very inspired. There's all sorts of scare stories about the Zoomers and the Zillennials or whatever they're called, just having their brains rotted by phones and stuff. But when I go to geoscience conferences, I meet people who are so much smarter than I ever was at that age,
Hmm.
and they're really engaged in these issues. So I do think that's encouraging. I think younger people will be engaged in this in it in a way that is not the case um, for some older generations. Uh, I think when the stuff starts hitting the fan in sort of the financial industry with, like I was saying, insurance and,
Right.
you know, some countries defaulting due to like climate um, catastrophes and stuff, the world is just gonna have to wake up and do something about it. And I wish it wouldn't take it getting pretty far along, but again, as I was saying before, like if you're going to look for an inspiring thing about our species, it is how good we are at responding once things get bad and how adaptable we are. So I think, yeah, things might, I mean, I do quote that primatologist in the book who thinks, yeah, based on her reading of the ice ages, you really need to go through some bottlenecks in order to innovate and uh, adapt to the world. So I hope that's not what it takes. But I
Yeah.
mean, we are different too. We have culture, and we can respond to things before they actually happen, which just makes us unique.
Yeah. And then I have a couple questions from Deb. She says, "Do you have hope that enough humans will eventually understand the carbon eruption we are causing soon enough to make the changes required?"
I think that's like similar to the last question, that
Yeah.
that's the hope, I guess. And yeah, it'd be great if we could academically understand this stuff before we get a physical demonstration of it. But another thing could be that if it's true that renewables plus electrification and things is just better technology, like that's sort of a best case scenario and you're just stupid not to adopt it. And if you don't, you get left behind in the dust as, a country
Hmm.
then that would be a great scenario. And in fact, the book ends on sort of a dour note about how hard decarbonization will be. But I think I would have made it a little less depressing if I had even handed in a final draft a few months later, because some of the advances in this technology really seem pretty incredible. And it does seem like it might just be better technology. Like not even worrying about like, can we convince enough people this stuff is real? But if they just like you're not driving a horse and buggy around anymore. And if it's just the case that it's better stuff, then I guess that would be a kind of painless way to you don't have to worry about convincing people. They'll just have they'll will make the switch because it's better stuff.
Yeah.
I hope that's the case.
Yeah, me too. Do you think her next question is, do you think technology will have a critical role in protecting our fragile environment?
Yeah, going back to what I was saying before, but now to completely contradict myself, I think some people are too flippant about the idea, oh well, technology will save us. And it won't require any heavy lifting or any sort of there won't have to be any political project attached to it. It'll just sort of take care of itself because technology will save us. And um, once you engage with what decarbonization will take, you realize that's not true. So sometimes, like friends and family will ask me, "Oh, well, why we can just build a CO2 sucking sucking machine that'll take it all out of the air." So all this, we're worrying for no reason because obviously we'll invent this because it'll be so important too, and you'll make so much money if you do. Without realizing there are hard physical, like in our universe, you cannot make that machine um, economically because what it does is going to require an incredible amount of energy just from first principles because of this entropy stuff I talk about in the book.
Hmm.
Uh, and that unless you decarbonize, like the best case scenarios for taking CO2 out of the air is like on the, 2 to 4 gigaton a year amount, which would be a miracle if we ever did that. And we put out 40 gigatons of the stuff every year and it accumulates. So unless you're getting down to zero, that technology is just not going to help you out at all. Um, and I mentioned earlier, if we're going to decarbonize as a country, we need to double to quintuple the capacity of the U.S. electrical grid, and that'll cost more than the interstate highway system, inflation adjusted dollars. So that seems like a big lift uh, that will require, that will have to go through the sausage making of politics to get something like that pulled off. So at a certain point, we need the technology, but as with all technology, it's how humans deploy it. Because technology is, nothing on its own without the institutions and societies that it's serving.
Yeah, would you say the best investment is really just clean energy and not necessarily things like carbon capture and solar geoengineering and like
I think people are gonna be too tempted to solar geoengineer that they're gonna do it.
yeah.
Um, I really don't think they appreciate how little we understand how that would work or what the effects would be. The people who are most skeptical of solar geoengineering are geoscientists. Uh, who understand how complex the planet is,
Yeah.
and that just just pulling one lever could have all sorts of unintended consequences, like changing weather patterns and where agricultural regions like the Indian monsoon might change where rain is, and which would cause drought and all sorts of human suffering. And if you're a country and some other country starts putting stuff into the air to block the sun, and suddenly like your agricultural yield goes down, like that could lead to a war. Like who knows?
Yeah.
So I'm sort of the mindset that we already have a complex problem enough as it is to figure out this. Let's not make it more complex. And once you start putting stuff into the air to block the sun, you have to keep doing it for thousands of years until you get like CO2 down to nothing. Because if you ever stop, then it will rain out of the atmosphere, and then the CO2 will still be there, so the temperature will spike. In like a decade, you'll suddenly have like 4 degrees of warming, and that would be a shock to the planet that like would be like unimaginable. So that stuff scares me. But I do think that if we don't get our act together and see if it just gets warmer and warmer, I think the temptation to do that will be stronger.
Yeah. So I have two more questions before we wrap up here. Um,
Mhm.
so what do you hope readers take away from this book?
Um, well, I hope I mean, not, it's not a politically relevant feeling, but I hope they take away what I took away from the book, which is just like this sense of awe of this planet and life itself. And, you know, yeah, I mean, I guess I can maybe being like just what a privilege it is to have a couple decades to explore this weird planet and try to understand how it works and how I got here and how like why I woke up in the first place on this strange place. Um, and so that is the process of researching and writing the book. Well, that will stay with me like for the rest of my life. Is just like this sense of cosmic wonder about what a special, miraculous, habitable place this is. And then, the political implications of that are like, once you realize how good we have it and what a miracle this planet is, how shameful it would be to just, trash the place. We show up and in a couple centuries we trash the place because we have it so good and we've been given such a like an incredible planet. So even there, I mean, that's another like motivation act on climate change. It isn't like sort of a typical one that you would hear. It's just like this sense of cosmic like gratitude about what a special planet is. And so I think that would be the sort of overriding thing. I don't view this as, there's much more practical books about climate change or much more um, ones that'll tell you about, yeah, decarbonization and all this stuff. And that wasn't the book I really wanted to write. I wanted to put it in this sort of planetary cosmic context. So if it would just, yeah, that's what I would hope.
Yeah. And so this is also probably the soonest I've interviewed someone after the publication of their book.
Mm.
So it might be too soon to ask what you're working on next, but do you have any thoughts or plans regarding new projects?
I've written couple stories and really had my imagination fired by, I've written about what's been happening, what happened in the last few 100 million years and all these deep, deep geological past. But a lot of those same people, you get some data points from some time period, hundreds of millions of years ago, and then you try to figure out what that world looked like. And they're doing things like making climate and Earth models of like these ancient planets to really understand how they worked.
Hmm.
But then they're using those same models and projecting them into the future. And so I'm really interested in this idea of like, what do we know about our deep geological future? So you have people working on like where the plates will move over time, what future plate tectonics will look like, and then what future climate will look like, given where the plates are and what
Hmm.
volcanism is doing, and how the sun is slowly getting brighter over time. And they're building these weird climate models for like hundreds of millions of years from now, what that world's going to be like. And
Hmm.
I just think it's I can tell that it's like firing my imagination. And I don't know if it's a book length project, but like, what do we know about what the Earth will be doing? And like on these like what does the future of Earth look like for not the next few centuries or decades, which is what people care about, but because I like this deep time stuff, it's like, no, what do we know about the like rest of the biography of the planet? Because there's some really fascinating stuff out there.
So you kind of want to focus on like the future of Earth in a kind of unique
Yeah,
geological way. Yeah,
yeah.
that's cool. All right. So, well, Peter, thank you again for joining us and writing a book that fundamentally reframes how we think about climate change. The story of CO2 is the story of everything places our current moment within Earth's much longer physical history, which is immensely fascinating. Um, Before we wrap up, where can our listeners find your work and follow what you're exploring next?
I'm on, I don't use it as much anymore, but Twitter, Peter Brannen one is the my handle. And then I'm on Blue Sky too, but the names are kind of complicated on that. I forget what, but if
Yeah,
you
they
just
are.
look up my name, yeah, you'll find me on there. And thank you all for reading a very long book that's really like really tough geochemistry and stuff. And so I'm glad you made it through it and you found it useful.
Yeah. Thank you again, Peter, and everyone listening. Thank you for tuning in to the Science Book Club podcast.
Thanks much, Mick.
And so, fellow travelers, our journey with Peter Brannen draws to its close. May his exploration of carbon's long history stay with you, reshaping how you think about air, energy, life, and responsibility. The story of CO2 reminds us that the forces shaping our future have always been with us, and that understanding them is the first step towards wisdom rather than reaction. Those wishing to enlist among a global crew are most welcome. Simply search Science Book Club on Facebook and join us for future voyages. End of transmission.